Welcome back, everybody. Today I'm going to go over two proofs. So you should have gotten this handout from your teacher, 7.1.4, 7.1.5. And if you didn't, go ahead and push pause, and you want to copy down kind of the structure of the proof, because what I'm going to do is go over the missing blanks. So altogether, we'll end up with a final formal proof. So when starting a proof, what I always look for first is what information is given. In this case, it's given ABCD is a rhombus. So this shape right here is a rhombus. So I can actually make that statement. ABCD is a rhombus. How do I know? It was given to me. All right. Then the next thing I always ask myself is, what do I know about rhombuses? Well, I know all the sides are the same. And in fact, that's what got written down here. One of the things I really want you to do is what I call dirty the picture. Whatever information I know, I'm going to go ahead and mark it on the picture. AB is congruent to CB. So AB is congruent to CB. DA is congruent to DC. And in fact, they're all congruent to each other because it's a rhombus. And in fact, if you really wanted to, you could put that symbol right inside there. They're all congruent to each other. How do I know that? Again, it's because I knew it was a rhombus. That's the definition of a rhombus. So I'm going to write down that reason. All right. Now, typically do at this point, all right, so I got all my given information, and I need to pause for a second because what is my goal? My goal is to prove these two angles are congruent. Typically, that's how we're going to end our proof because that's how we know we're done. So I know angle ABD is congruent to angle CBD. So now I have a direction of where I want to go. I want to get to the end where I can say this little piece is congruent to that. I don't mark that because I don't know it yet, but I know that's where I want to go. All right, so how in the world am I going to be able to show that two parts are congruent? Well, I think to myself, if I can show these two triangles are congruent, then I can show their parts are congruent. So I'm part way there. I already know two pieces are congruent. So now if I just have one more piece, I can show that the two triangles are congruent. Well, in fact, I know that DB is congruent to itself. And that's true by the reflexive property. And if I wasn't sure, your teacher might give you some of the answers filled in there. So this is a reflexive property. What shows that? I'm going to show that these two parts are the same. Yeah, basically it's saying, hey, they share a side. The sides must be the same length. Now I can say the two triangles are congruent. So that triangle and that triangle congruent. So now let's write that out. Triangle DAB is congruent to triangle DCB. Again, how do I know that? I can see it right here with all my orange marks by side, side, side. And that was already filled in for me. Now logic goes like this. If I have two triangles that are congruent, then all of the corresponding parts, all the parts that match together must be congruent. And there's a shortcut way of saying that. What we say is corresponding parts of congruent triangles are congruent. That doesn't look too much like a shortcut, so I'm going to give you even a shorter shortcut. CPCTC. Corresponding parts of congruent triangles are congruent. And that's actually accepted in mathematics. People will know what you're talking about if you put CPCTC. But if you can't remember that, just write out what it says. All right, let's look at another proof. So go ahead and slide your paper over, or I will slide my paper over. So this one starts out a little bit different. What I have here is I know that two angles are congruent, and I want to show that this triangle is isosceles. So one of the ways we're going to start with something a little different is we're going to draw an auxiliary line. So we're drawing this line, FM. There's no M on here, so it's going to tell me what to do with M. FM bisects angle EFG, and point M lies on EG. So M sits on EG, and it's going to bisect this angle up here. I'm going to put the letter M right there. All right, so now what do I know? Well, they've already started us out. I'm given some information. So I'm given angle E is congruent to angle G. That's given to me. One. Angle EFM is congruent to GFM. So what they're saying is EFM is congruent to GFM. How do I know that? Well, it goes back to, it has to be one of these reasons. So it tells me up here that FM bisected EFG. What that bisect means to cut in half. So if I were to cut this angle in half, these two angles must be the same measurement. So I know those are congruent by definition of bisect. Right? I knew it cut it in half because that's what they said they did here. Therefore, these two angles must be the same. All right, next one down. Again, I made sure I dirtied the picture. I know it's reflexive, so I'm looking for something that's being shared. Well, FM, both of these triangles share FM. So FM is congruent to FM, line segment. So I'm going to put the lines right above it. So I know that because they are reflexive. They share the same side. All right, let's make sure I got, I never marked this. I never marked angle E and angle G, so I'm going to go ahead and do that right now. Angle E and angle G. So I always want to make sure I dirty my picture. I've got 1, 2, 3 things that should be marked on here. Now I can show that these two triangles are congruent to each other. So I've got triangle EFM is congruent to GFM. That's by angle, angle, side. All right, and then finally, remember, my goal is to show that this is isosceles. So I really need to show that two of the sides are the same, right? That's a definition of isosceles. So I can show that this must be the same as that. So EF is congruent to FG. And that's because I know my parts are the same. So C, P, C, T, C. Corresponding parts of congruent triangles are congruent. All right, so now that I know that these two are the same, this shape must be an isosceles because two of the sides are the same, right? That's a definition of what an isosceles triangle is. So I know that triangle's isosceles by definition of isosceles. And that's it. Now, I do want to say one thing. These are clear to me because I've been doing lots of proofs. So you have to do a bunch of proofs. It's not obvious to me all the time, especially if I do a problem that I haven't already done. So what you really need to do is do as many of these as you can, and even if you cover it up, try to do it again. All right? Thanks for watching.